Okay, so I'm going to pretty quickly go through a couple of examples of questions that we haven't seen before, and let's just see how we get through it. I'll try and be as fast as I can. Please ask questions as I go along if you're not too sure. Please feel free to write these down into your summary book. Basically, I might go faster than you're expecting to go, but don't forget these notes in the video will be here for you afterwards as well. Generally speaking, guys, I find like there's an old what's how does the old saying go? If I see, I how's it go? Can you remember it? If I see, I can't remember how it goes. But basically, writing stuff down usually, if you do, you understand better. So writing stuff down gets it into your head better, whereas just watching it doesn't. It's such a famous saying. Of course, I'd forget it. What is it? If I see a light flashing, the homies with the golf. Yeah, that's what it. If I see, I remember. If I do, I understand. It wasn't that hard, was it? And if I'm Richard, then I always forget. So that's the summary, I think. If I see, I remember. If I see, I remember. If I do, I understand. So this may be a good way of you understanding just simply by copying it down. While you're getting yourself organised, I'll just start up the. Well, I heard people are chatting whilst I'm getting stuff organised, and all I heard is something about a checkout. You know what? I don't think I do. Now, what I'm about to go through here is an AP example of the same kind that I went through on Friday. Sorry for Friday, people, where we went through a GP example of this. So the example is you're told it is an arithmetic progression, which means that each term is going up by a certain amount each time, or going down, could be increasing or decreasing. It's an AP, so we know it's going up by the same amount as opposed to a GP, which is being multiplied by the same factor. You're given the third and the fifth, and you're asked to work out what the 10th is. Yeah? So that's a scenario. How do we do that? We can't use the general form, the formula, because the formula requires A1, and we don't have A1 yet. Now, if you remember what we did with the GP, what we basically did is we sort of said, well, if I've got the third and the 10th term, that means I have to multiply the third by a certain number of times to get to the 10th one. We're going to use exactly the same logic for this one. So just to remind you, I'll put it in red so you can sort of see it here, just to remind you, the general form of the formula is that the nth term is given by the first term plus n minus 1 multiplied by d. That's the general term or the general formula for an arithmetic progression. What we can also do, though, is that we can sort of restart our beginning. So in this instance, we could do something like this. We can say, well, 17 is the term I know is the ninth term, and is the fifth term, and the fifth term is 2 terms further away from the third term. So if we kind of treat the third term as if it were the first, so we put it where A1 would be, and say, I need to add 2D to this, so D, and then another D, in order to get to 17, then I can now solve for D. Does that kind of make sense? It's basically the same logic as I did with the the geometric progression last lesson. To make it really clear, and that's all you need to do. Basically, this bit here is the last term you've got. This bit here is the first term you've got. And the number of D's I'm multiplying, so 2 times D in this case, is really the difference between these two numbers here. That's basically the process, but I want you to get the understanding as well. Go. So if we went to be asked that question, would you expect that? Yep. Doesn't. I can give you more complicated working out, but I think, is that logical enough for you? Yeah, so that's all good by me. Just for those who are going, what you did, the what now and the how now, what I'm saying is the third term is 9. The next term would be that's the fifth term. The next term is 9 plus D. That'd be the sixth. Oh my gosh, sorry. I was a little bit. Okay, the third term is 9. 9 plus D would be the fourth term. And so 9 plus D, or 9 plus 2D, would be the fifth term, which we know is equal to 17. That's the logic behind it, right? Okay, I won't belabor that. Bye-bye. Solve for D. So hopefully you can do that. Hopefully you're ahead of me already. Subtract 9 from both sides to get 8. Divide both sides by 2 to get 4. In this class, I hope that's good enough, guys. If you'd understand what I've done there, subtracted, divided. Okay, cool. So what? Done? No, because didn't answer the question. Thanks, Jack. So the question was, what's the 10th term? So we better answer the question. So we need to know what A10 is. That's the 10th term, right? And the 10th term, well, there's a few ways you can do it, but probably this is, well, anyone want to suggest a way we could do it? Probably the fastest way that you think, well, the most efficient way? What am I thinking? Who can read my mind? Otto. You literally read my, or you literally, you did read my mind. Good. Yeah, so we can sort of say, start the fifth term and add another 5 on, right? 5 lots of D. But this time we know what D is, it's 4. So the 10th term is going to be 17 plus 5, 4 is 20. So the fifth term must be 37. What do you reckon? Any questions? What happens if I go backwards though? What happens if I'm asked what's the first term? Okay, so I'll quickly do that. The first term, well, what I do is I pick on something that I already know, and the smaller the numbers, the less likely I make a calculation mistake. So I'm going to pick on the third term. So what's A1 is the question. What's the first term? So if I go A3, I know that's equal to 9. But I also know by the formula that it's equal to A1 plus 2D, which is 4. Okay, so if I know that 9 equals A1 and 2 times 4 is equals 8, then A1 must equal 1. Is that okay? Like I'm just sort of burning through those calculations a bit, basic calculations. Now, again, what you could have done is you could have gone, well, A3 is 9, so 1 back would be 5, 9 take away 5, 9 take away 4 is 5, and then 5 take away 4 is 1. So I could have just done that, which is fine, but imagine if you were given the 17th term and the 25th term. So again, like I said on Friday, often I use a really simple example to illustrate the process, but remember the process is scalable. Given 2 terms and the nature of the sequence, you should be able to work out any other term. Yeah? Okay, any questions before I move on to my second example? Oakley dokley. So, example 2. Okay, so the fourth term, so this is the setup. Hang on, I better say it's an AP as well. In an AP, the fourth term is twice the second term. The 10th term is 40. What's the first term? Now, normally I'd probably give you a bit of time to think about it, discuss it with the person next to you, but I'm just going to get stuck into it so I'm not spending too much time. Okay, so you can see here, it's quite tricky. Like, this is an advanced one for this year, really, in that you've been given a specific term, you've been given a relationship between two terms, but that's what, and you've been told it's an AP and that's it. So you've got some fairly disjointed information. If you think you know how to solve this, solve it before me, please. It's really good if you do that, because then I can go back and go, did I get it right or not? So in this particular question, I cannot emphasize enough that what a mathematician does is a mathematician starts. Okay? A mathematician doesn't go, here is the answer, but a mathematician will go, how can I connect my facts together and see where it takes them. So, for example, I can start off with this. Let me see. A4 is equal twice A2. I know that. I also know that A2 is A1 plus D, so it's twice A1 plus D. What else do I know? Well, I was given a fact about A10. So A10 is equal to 40. I know that, so I was told that. But I also know from the general form that A10 also equals, can anyone say? You can just yell it out this time, don't need to raise your hand. Go, keep going. Yep. Okay, so I've got some facts here. Where do I go? Where do I go? Where do I go? Oh, well, I also know that A4 is equal to A1 plus what? Someone else shout it out. 3D. Yep. A1 plus 3D. Okay, so I've got that. Let me see. I've used that fact, I've used A1 plus D already in the top bit. Okay, I've kind of run out of facts to write down. Now I need to start linking them together. And have you noticed that, I don't know about you, and this is supposed to be an organic process here. Have you noticed that these two things are sort of give us a relationship? We've got A4 equal to 2 multiplied by A1 plus D. We've also got A4 equal to A1 plus 3D. So we actually have a relationship there. We have two facts that are linked by the fact they're both A4. Does that kind of make sense? And can you see how it's a journey? It's not like me going, the answer is 7. Why? Because I can see it, I'm a mathematician, and I'm just awesome. That's not how it works. We write facts down until we can start seeing a relationship. We use I wouldn't normally harp on about this, but your Maths Extended students, this is what you need to know is how you go about stuff. Okay, it's not about knowing the answer, tripping from your mouth. It's all about the process. It's all about being able to link stuff together. Okay, so let's link those that stuff together. So we can say, it's changing colour, therefore 2 outside of A1 plus D is equal to A1 plus 3D. All right, that might get us somewhere. Don't know yet, we'll see. Shall we simplify it? Shall we collect all our like terms together? So all the A1s together and all the Ds together. So I'll expand that first. So that would be 2A1 plus 2D is equal to A1 plus 3D. So if I subtract A1 from both sides, I'll get A1 plus 2D equals 3D. Oh, hang on. And at some point, you'll get a click, I hope. You might not in this problem, but I'm saying as a mathematician, as you're figuring things out, you might get a bit of a click. And here, I've just gone, oh, hang on. If I take 2D from both, oh, okay. So the relationship, if the fourth term is twice the second term, the relationship is that the first term must be the same as its difference. In other words, if the first term is 1, then the difference will be 1. The second term is 2, then the difference will be 2, etc., right? If the first term is pi, the difference is pi. It doesn't have to be a whole number. So I've got that. I still haven't really used the 10th term, though. So far, it could be lots of different sequences, like I just said. But that 10th term is 40 I haven't used yet. Wait, hang on. Okay, let's use, this is like in the optimization unit where we have another constraint, right? We've got this relationship that the first term and difference is the same. Our constraint is that the 10th term is 40, so we've got to use that. And in the middle there, I can see that I've got A1 plus 9D is equal to 40. Now, this is good news for me. Okay. So A1 plus 9D equals 40. And it's good news because, now normally we can solve an equation with one unknown. This still has two unknowns, but what can we do next? You just walk in. Yep. Remember, the name of the game is to get it down to one, like in the optimization unit, the name of the game is to get it down into one variable so that we can solve it. Hamish.
Well, we know that 1 day is equal to A1 squared is equal to D, so it means that 10 days is equal to 40.
So you've replaced A1 with D? Either way. So what, hey, look, I'm going to go back a step. You went one step further ahead, which is great. But we can now replace A1 with D. Or we could replace D with A1. Doesn't matter, does it? So we've got D plus 9D is 10D, which is equal to 40. And so D equals 4, and that equals A1 by a relationship. We were asked what the first term is. Oh, we've done it. There's nothing more that needs to be done. We've got it. Yeah? So again, it's about using the facts that you've got in order to solve the problem. Don't expect to always get a problem that you have seen before and therefore you can just copy that way. A good mathematician builds up skills in saying, well, what do I know? What have I been given? What tools have I got to give me new facts? How can I link these facts together to solve the problem? Developing those skills is what makes a good mathematician, or will turn you into a good mathematician. Okay, does anyone have any questions about that before we get you onto booklet work? Hannah.
Like, how did you know that this term was
in slide 7 here, we linked the fact that this was A4 twice A1 plus 2D, so it's basically that. We linked that fact with the fact that A4 is also A1 plus 3D, which is what I have on the right here. These two things must be equal because our problem told us that A4 is twice the second term. That gives us this. And our knowledge of arithmetic progressions tells us that A4 is also equal to that. So in this particular context, this particular problem, A4 is equal to that, and A4 is equal to that. If A4 is equal to that and A4 is equal to that, then it must follow that that is also equal to that, which is what I have here, which then gets expanded and solved. The end result of this is that by collecting like terms, I get the relationship that for this bit to be true, the fourth term is twice the second term, it must be that the first term is equal to the difference. Yeah, in this example. And then I could use that fact in slide 8 here. Okay, this will all be in, thank you, Hannah, that was a really good question. And the thing I love about questions, particularly when I'm recording in front of a class, is it means that question is captured in the video as well, which then gets put onto Google Classroom. So that might help solve a few problems as well. Does anyone have any other questions? Okay, so this is what we want you to do now. This really is pretty much what you have done, what you was doing on Friday anyway, but I'm going to be a bit more targeted with what we want you to do. So get your booklets out, please. While you're doing that, I might stop the video because it's a bit of a boring into the video otherwise.